Hi, and welcome to the video component of the True Margin device. I'm just going to try and illustrate some of the pitfalls and alignment errors inside the Cryostat. This here is the knife holder. It's held in place by this T-slot, which ends up being just a pivot point, and its swing is only limited by this tongue and groove here. This error actually represents, on average, about 120 microns over a 25 millimeter sample, and I've seen this go up to about 450 microns on some machines. Every adjustment is a potential alignment error. The worst one is this one right here, the XY adjustment. It's supposed to allow you to compensate for any misalignments, but you do it by eye. It's actually very difficult to move in one plane without affecting the other. There's some detents here to bring you back to a theoretical zero. As you can see, it's not very positive, a lot of play, and I don't know if you saw that, but just locking it even moves it out of alignment. So the detents happen to be out about 475 on average microns, and it can go up to about 800 microns on a 25 millimeter sample, and just locking it moves it out a further 105 to about 140 microns. Now, right here where the specimens go, this chuck right here, I took one out from another machine. Now it's loose now, and the back of the chuck and the object holder, it's a nice tight fit, but as you tighten the set screw to lock it into place, it actually cants the chuck up, and now you've introduced another 100 micron error. These things are really starting to add up. What we do is we just lock everything down, let it be as it is. We're going to make a test block just for simplicity here, because this machine is warm. I made this with some epoxy. I don't know if you can see, but it's actually a little crooked. It's because I cut it, so it's whatever error happened to be in that machine. What you do, you pop it in here. I line up the witness marks. I lock it into place. I bring the top plate down. I don't know if you can see, there's a gap there. It's not aligned, but when you loosen the ball joint, it slips into place. The face of the block and the top plate are aligned. The tool is now zeroed. Every other specimen that gets prepared on this, although it looks like it's off, it's definitely a big gap around here. It's actually perfectly adjusted for this particular machine. All right, here we are in a cold Cryostat. Basically, I'm just going to show you quick. This is just a block of embedding medium, just the regular stuff that we use every day. It freezes about -20. You just make a test block. You just pop it in here, zero the tool. It's zeroed, and we're ready to cut. So what I'm going to do is I'm actually going to embed something while we're waiting here. Just going to let this start to freeze. It's just a piece of liver I bought at the grocery store. It's not human liver or anything, and it's just starting to freeze. I'm going to put a little embedding media around it, and you can see it's going to start to frost over. There we go. Gotta transfer this over here, lock it in, bring that down, let that freeze. Just to illustrate, this is one I just froze earlier. Just going to pull that off. Kind of hard to see. Whoop. There we go. But basically the whole face of that, there's just some little irregularities in the surface of that tissue, but it's all right there. And I don't know if that one would be ready, but we can try. It's another one I did, for illustration purposes. I'll show you a second one. It's kind of hard to judge that first cut. Nope. See what we got here. Pretty much the whole thing right there. And if this one's frozen, we're in business. Show you. It's kind of hard to work with the camera in the way. Kind of feel uncoordinated. See what we got. Whole thing. Magic.